Hi students, recently we have seen that CBSe has considered this pandemic situation very seriously, and accordingly they have revised the syllabus for class 9, 10, 11 and 12. Okay, so today we shall discuss about the class 12 physics syllabus, how much portion of the physics syllabus has been deleted and how this is going to affect in your near future career. So if we look at the number of periods, initially it was 160 periods, now it has been reduced to 118. So almost 42 periods has been deleted, has been reduced. So if we consider in a percentage wise, 26% has been reduced by the CBSe board or NCERT people. Now the question is how this deleted portion is going to affect in your near future career, because when we part of some traditional situation, then we have to look at a lot of things. So we shall discuss today those portions one by one. So in class 12 physics, if we divide volume 1 and volume 2, then in volume 1 we see that there are 6 chapters. In 6 chapters, if we look at the deleted portion, then in electrostatics, chapter 1 electrostatics, what we learn here, we learn mainly the electrostatic force and electric field. So by Coulomb's law and by using Gauss's law, you find out the electric field. So here what is happened, this thin spherical shell has been deleted. Okay, this thin spherical shell is one of the application of Gauss's law. By using Gauss's law, you find the electric field. So this three-dimensional application of the Gauss's law has been deleted, but one-dimensional and two-dimensional is there. That is electric field due to a wire, electric field due to a plane sheet is already there. So I don't think that this is going to create any kind of problem in your near future, because already you know what Gauss's theorem is and what is the application of Gauss's theorem for one-dimensional and three-dimension. So this is not going to be a big question for you. For second chapter, there is no change. Okay, already electrostatic potential and capacitance is already a small chapter, so nothing has been reduced here. So you have to learn how the capacitors are arranged in series and parallel, and you have to learn how this potential and capacitances are related. Okay, then you come to chapter 3. In chapter 3, you will see that the first portion, that is carbon resistors and color code. By using color code, you can find out the resistance of carbon resistance. Right? So this portion has been reduced. Some of the students learn at class 11 practical classes how to find out the color code combination in carbon resistances. So this is also not going to affect anything in your career. But look at this series and parallel combination. Initially, it was considered to be very important for selective examinations, right? Test, your medical test, engineering test. For those, this series and parallel combination of resistances were considered to be very, very seriously. Now, since it has been deleted, okay, since it has been deleted for your CBSe board exam, so you have to look at whether this portion will be deleted in your future entrance examination or not. If it is not deleted from those syllabuses in your entrance examination, then you have to again come back after your board examination. So take it very, very seriously. Again, another question is in my mind that though this series and parallel combination of resistance has been reduced, has been deleted, but in the practical syllabus, they have given the series and parallel combination by using a meter base. My question is, if it is deleted from the theory part, then how one can learn in practical classes? So that's a question for me always. But whatever it is, this is a big portion, big fear factor for the student has been deleted. So for you, it is a good thing. Okay, your portion has been reduced. Then look at this chapter 4. From chapter 4, nothing has been deleted, only cyclotron has been deleted. Cyclotron is an accelerator, whether such particles are accelerated. Okay, it is an accelerator. But here you see, in cyclotron, the basic principle of Lorentz force is used. Okay, Lorentz force F is equal to BQV sin theta. When a charged particle passes through a magnetic field in perpendicular direction, then it travels in a circular path. This principle is used. Okay, but this principle mv square by r is equal to BQV sin theta sin 90. So it is your sin 90 is 1. So ultimately this principle is used here. Okay, so though this part is deleted from your syllabus, but you don't delete this part because this is a very important concept in magnetism chapter. Okay, so you can avoid the working examples, all these things in cyclotron part, but this mv square by r is equal to bqv, this is going to be a very important parameter. This is important principle in your near future also. Then look at this chapter 5. In chapter 5, initially it was actually a big chapter, an ornamental chapter. This magnetism and matter, in this part, you had initially bar magnet. In case of a bar magnet, you are to find out the magnetic field along this axial line, you are to find out the magnetic field intensity along this equatorial plane, and you are to find out the torque due to a bar magnet. Okay, now this portion has been deleted. So though this portion has been deleted, the concept of electrical dipole in first chapter, you have learned how to find out the electric field on its axial line, on its equatorial plane, and the torque due to a dipole. The same concept is used here. So if you avoid this part also, conceptually you are not losing anything. So you can easily avoid this completely from your learning parts. And again, another looking at this property of magnetism, we can classify into diamagnetic, paramagnetic, ferromagnetic materials. Okay, so this classification, and then electromagnets and to be ornament only. So when you avoid this, when you completely delete this, it is not going to affect in your near future. If you learn electrical engineering, then of course you have to learn electromagnet and permanent magnets. Okay, and if you take physics as a major subject, then also you can learn in the later near future. Look at this chapter 6. Chapter 6 is already a small chapter, so nothing has been deleted from here. So this electromagnetic induction, you have to learn here Faraday's law, Lenz's law, self-induction, mutual induction, only those portions are there. So this is a small chapter and nothing has been reduced here. So if you look at this volume 1, physics class 12, then my only question is on this portion. Okay, and you have to look back at this principle. Other things are okay, you can remove from your syllabus completely, no problem. Okay, now come to your volume 2. In volume 2 you have 7 chapters already. So chapter 7 you have alternating current. In alternating current you will learn what are RMS voltage, what are RMS current, LC oscillation, LCR circuit, all these things you will learn. Only a small portion, that is power factor and wattless current. When you derive the powers in terms of AC sources, then you get two components, power factor and wattless current. This portion has been deleted. So in general we got only some numericals from power factor and wattless current. Since this has been deleted, it is also not going to affect anything in your future. Look at chapter 8. In chapter 8 only one portion has been deleted, that is the idea of displacement current. For class 12 student, of course this is a big concept to understand what displacement current is, but in physics this displacement current has a great importance, as Maxwell introduced this term in deducing the electromagnetic theory, and he got the Nobel also, Nobel Prize also for you can say that for this term only, because for this term he was able to combine those theories. So whatever it is also not going to hamper anything in your near future, because if you consider physics as your career, then you have to learn it later on also. Okay, then look at chapter 9 and 10. In chapter 9 you have ray optics. This is a big chapter. Ray optics, you have reflection and refraction. If you consider ray optics, then you can divide into two parts. One is your reflection of light, another is your refraction of light. So from refraction of light, nothing has been deduced, nothing has been deducted. Only thing is that in reflection of light, this spherical mirror formula 1 by u plus 1 by v plus 1 by, is equal to 1 by f, those portion, and then scattering of light, why the color of the sky is blue, those part has been deducted, that has been deleted. So this is going to reduce some weightage, but since you have already learned what spherical mirror formula is in class 10, so conceptually you are not going to lose anything here also. In wave optics, if you see, then The last portion of the diffraction, that is the resolving power for microscope and astronomical telescope, that has been deleted. And if you see that the polarization, almost polarization whole scepter has been deleted. So this is a good reduction for you. And for diffraction also, almost 30% of the diffraction scepter has been deleted. So here in wave optics, interference is going to be very important for you, considering the examination. Okay, board examination, interference is going to be very important part for you. Then look at this scepter 11. In scepter 11, you have dual nature of matter and radiation. Actually, this is the starting of your quantum mechanics. Here, we basically learn the wave nature and particle nature of electron. Actually, all particles have both this dual nature, but here we insist on electrons. And Davisson and Germer experiment prove the electron as a wave by using the concept of diffraction. So this portion has been deleted. Only this portion, Davisson and Germer experiment, has been deleted from your this part. So I don't think conceptually you are losing anything because this is an experiment only. Then in scepter 12, they have not touched anything. Atoms, it is as it is. So you have to learn the full concept of atom. Okay. Then in scepter 13, they have reduced a big portion. The radioactivity portion has been completely reduced. Here you have to learn the concept of nucleus, the nuclear force, the charge, the size, all these things you have to learn, but you need not to learn anything about the radioactivity, half-life, okay, then alpha, beta, gamma, what are their properties, you can reduce those portion. Also the binding energy curve has been reduced, okay, so you need not to learn this thing, but you have to learn the mass defect, size, charge and properties of the nucleus. So almost 50% of the nuclear part has been deleted, so only 50% of the nuclei is there. Atom is already there. You have to learn what is Rutherford's model, Bohr's model, those atomic spectra you have to learn here. And in sector 14, you have to learn only those diode part. Okay, in semiconductor devices, the diode characteristic you have to learn. You have to learn what is forward characteristic, what is reverse characteristic, but you need not to learn what is Zener diode. Initially, Zener diode was important for electrical circuits. Now, since the transistor part has been already deleted in the last year, so Zener diode is now deleted. So this is a very small scepter. So considering the volume of scepter 13 and 14, it will give you a smile in your face, right? This is a very small portion considering the volume. So in volume 2, if you look at the maximum portion is which is deleted is your this part, okay, optics part. So initially it was a very big scepter. Now it has been at least deleted some portion and some reduction is there. So we have learned what we have to delete exactly and what we have to look back after the examination if those portions are not deleted from the entrance examination. So look at those points. So you have to be very, very careful when you are appearing for any other test examination, whether those syllabus is covering this deleted portion or not. So you have to be active enough after the board examination. So best of luck. Just go on doing this thing. You will get your result.